My name is Sophina Taitano. I'm one of the researchers at the Anschutz Medical Campus, and I'm here to talk with you about how vaccines work. And to understand how vaccines work, first we have to understand your immune system. So your immune system is your body's army, and it's protecting you every day against pathogens. And a pathogen can be a bacteria, a virus, or a parasite that can cause disease. Your immune system is made up of many different types of cells, including dendritic cells, B cells, and T cells, which we'll talk a little bit more in depth later. These cells of your immune system are constantly circulating throughout your body, using your lymphatic system and your blood vessels to get around. So they're constantly circulating because they're patrolling and they're looking for these pathogens. And when they see a pathogen, your immune system army activates. So if your immune system is your army, then your dendritic cells would be like your commanders. So they're the first ones to give the order for an attack. Your T cells would be like your captains. So they get the orders from the dendritic cells, and then they tell the rest of the army what to do. Your B cells are like your privates. So they're the muscle of the army. And they go out and they help to eliminate the pathogens. And your pathogens, of course, are the enemy. So, what's your name, ma'am, in the front?
I'm Marissa.
Marissa? Okay, Marissa. So it's flu season. Let's say you got the flu, okay? And let's see how your immune system is going to deal with that. Okay. So when you get infected by a pathogen, like the flu, your dendritic cells can engulf these pathogens, break them down, and then present them to your T cells. And this is important because this teaches the T cell what the pathogen looks like, and it activates these T cells. These T cells then can go on to activate many other cells of your immune system, including B cells. So these B cells can then start to produce these molecules that we call antibodies. And antibodies are able to attach to whatever pathogen they were activated towards. So in this case, the flu. These antibodies can help protect you and eliminate the pathogens in 3 different ways. They can cover the pathogen so then it can't infect you. It can coat the pathogen so that other cells of your immune system can more easily identify it and eliminate it. And they can also recruit proteins that can directly kill some of these pathogens. Once your immune system eliminates a pathogen with the help of these antibodies, the B cells continue to make these antibodies for a while, and these antibodies will circulate through your blood system, which is important for the next time you encounter this same pathogen, which we'll talk about. Okay. So once your immune system learns what a specific pathogen looks like, then the B cells and the T cells can activate much quicker. And then these antibodies that are now circulating in your blood can bind or attach to these pathogens and help slow down the infection. So this is called memory. So you taught your immune system what the pathogen looks like, and now it remembers. So it seems like your immune system can really handle whatever infection you get. So why not just get infected and build that memory that way? Well, who likes to get sick, right? Nobody likes to get sick. You don't feel good, and part of the reason you don't feel good is that activation of your immune system. So when your immune system is active, you can have this redness and swelling, which is the recruitment of those immune cells to the infection. You can have heat, which is like a fever, and that helps to slow down an infection. And then there's also pain. And while these might not seem to be that bad, depending on the infection, it can become very severe and life-threatening. On top of that, the pathogen itself can cause a lot of issues like diarrhea, vomiting, paralysis, which can result in permanent disability and even death. So why wouldn't you just get infected? Well, you put yourself in a lot of unnecessary risk. Okay. So vaccines are trying to mimic these infections and get you this memory without getting you sick and without all of those unnecessary risks. Vaccines, instead of using a whole pathogen that could make you sick, it only uses parts of a pathogen. And these parts of a pathogen are enough to give you this memory and protect you against later infections without getting sick. So now that we know how vaccines work, they teach our immune system about a certain pathogen and help protect us against that kind of infection later on, what's actually in a vaccine? So we talked about there being parts of a pathogen in a vaccine, and that's important to be able to teach your immune system what that pathogen looks like. There are preservatives that help prevent bacteria and fungus growth. So you don't want bacteria and fungus growing in vaccines while they're in storage or in transport. Adjuvants are things that are used to help activate your immune system. So that's also in vaccines. And then there's stabilizers, which help to maintain the effectiveness of a vaccine while it's being stored or while it's in transport. So there's a lot of concerns about vaccine safety, and a lot of them revolve around these components of the vaccine. So let's talk a little bit about that. The first one is thimerosal, and that's a preservative, so it prevents the bacteria and fungus from growing. The concern with this is that it contains mercury. And so when people think of mercury, they think of methylmercury. And so methylmercury is what you can get from eating contaminated fish. And if you eat a lot of contaminated fish, you can get methylmercury at high levels, and that can be toxic and dangerous. But in vaccines, it's actually ethylmercury. And so it's very similar, but it just has this extra carbon and 2 hydrogens. So a small difference, but ethylmercury accumulates less within the body, and it's not toxic at high levels. So you might be wondering, well, how does 1 carbon and 2 hydrogens really change it from being toxic to non-toxic, right? Well, if we think about methanol, methanol is what you put in gasoline so it doesn't freeze in the winter. But if you drank it, you could go blind. But if you just add a carbon and 2 hydrogens to methanol, now you have ethanol. And ethanol is the fun part of wine and beer, right? And if you drink a glass a day, it might even have some health benefits. So these small differences can really make a big change. In terms of thimerosal, though, it's no longer used in childhood vaccines, so it's not as big of a concern, but you might come across it in your research. Another preservative that people are concerned with is formaldehyde. So formaldehyde at high levels can cause cancer, but this is really only a concern with people that are working with formaldehyde every day and breathing it in. And while formaldehyde might sound like a scary thing that we make in the lab, it's actually naturally occurring. So many plants and animals make formaldehyde, and it's important for their health. So every time you eat your fruits, your vegetables, your meats, and your cheeses, you're consuming formaldehyde. And even you make formaldehyde. And it's important for your health as well. So here the concern is about high amounts of formaldehyde, but what amount of formaldehyde is in a vaccine? So here, in the pair on the left, the blue shows you how much formaldehyde you would consume from just eating 1 pear. And the pair here on the right, the blue shows the amount of formaldehyde you would get from a normal vaccine. So it's a very small amount compared to the amount that you consume every day, because I'm sure we're all eating more than 1 pear. You might also think, well, younger children might be more susceptible. But newborns, since we all make formaldehyde, already have 50 to 70 times more formaldehyde in their blood circulation than in any vaccine. And Okay. Oh, and there was a study that was done that looked at, after a vaccine, how did that change the levels of formaldehyde within the blood of an infant? And at most, it changed it by 1%, so very minimal. Additionally, some lab experiments have given 600 times the amount of formaldehyde to animals, and it was still found to be safe. Which, if you think about how much formaldehyde was in that one pair compared to one vaccine, it makes sense. Okay. So next is the adjuvant, so that part of the vaccine that helps to activate your immune system. So the adjuvant used in the United States are aluminum salts. And the concern with aluminum salts are that it can cause bone and brain disorders at high concentrations. But this is really only a concern in people with kidney failure because they're not able to get rid of that excess aluminum, or people that are on medications that are very high in aluminum. Vaccines have been using aluminum salt since 1930, and vaccines are continuously monitored for safety. So since 1930, no major adverse effects or bad reactions have been reported due to aluminum salts. Additionally, there was a study that looked at the levels of aluminum salts that a child would have within their body due to vaccines over the first year of life. So here on this axis, this is the amount of aluminum, and then on the bottom is days and age, so over that year of their first year of life. This blue line shows the minimum risk level. So this is the level of aluminum that has been shown to have, anything below this has very little risk. And so you don't want to have aluminum levels within your body above this level. In the black line, this is the amount of aluminum that a child will get due to vaccinations over that first year of life. And on the bottom, this is the amount of aluminum that an infant would get due to just the consumption of breast milk and formula. So while the amount of aluminum contributed by the vaccines is a little bit higher than breast milk and formula, it's still far below this line that tells us where risks start. So again, this is an instance where high levels of aluminum salts could cause problems, but the levels that are in vaccines are very low. Adverse reactions to vaccines, or having a bad reaction to a vaccine, has also caused a lot of concern about the safety. So let's take a look at why you would have a bad reaction. Well, maybe you have a reaction to something that's in the vaccine. Maybe you're allergic to something in the vaccine. There could be issues with the quality of the vaccine, so that happens at the manufacturing facility. Or you could have your nurse or your physician improperly administer the vaccine. But all three of these are highly regulated. So before a vaccine even comes to the public, it has to go through many different trials, and most of those trials are just looking at safety. And even once the vaccine is given to the public, it's continuously monitored to make sure that we didn't miss any very rare adverse effects. These manufacturing facilities are also constantly under surveillance, and they have to undergo many inspections to make sure that they're putting out high quality vaccinations. And then your nurses and your physicians are also extensively trained to give these vaccinations. Another reason could just be anxiety. Nobody likes to get a shot, right? So that can cause some anxiety, can make you feel dizzy, you could faint or even vomit. And it could also just be coincidence. So just because you got a vaccine and then something bad happened doesn't necessarily mean that it was caused by the vaccine, right? So if we looked here, in purple, this is the individuals diagnosed with autism, and we see that it's increasing over the years. But it's also increasing right next to something else. Does anyone have a guess of what that might be?
Vaccines.
Vaccines? Organic food cells. But we don't think organic food cells are causing autism, right? So just because one thing happens before another doesn't mean that it caused it. Another thing to keep in mind is that with vaccination, you're activating your immune system, right? And so we talked earlier about what can happen when you activate your immune system. You can have this redness, swelling, heat, and pain. And so 10% of people that get vaccinated have these minor adverse reactions, which most of the time is just redness and swelling at the injection site, or it's a slight fever. So these things are things that you go home and you can take care of with Tylenol, or it'll just go away on its own. So these can usually be explained by just immune activation. So your vaccine's actually doing what it's supposed to. But severe adverse reactions do also occur, but in less than 1% of people. And these are mostly due to allergic reactions. So you might be allergic to something that's in the vaccine. So it's important that when you're going to get a vaccination or you're talking to your doctor about vaccinations, that they know what your allergies are, so that if that might be in a vaccine, you can talk about other alternatives, because you don't want to have a severe allergic reaction to your vaccine, for sure. Okay, if that didn't convince you and you're still wondering, well, why even take the risk of getting a vaccine? Well, vaccines are important for you, but they're also important for your community. So infection is a chain reaction. Some of you got popsicle sticks when you came in. If you have a red popsicle stick, can you please stand? Okay, so you are infected, okay? Okay, so remain standing. If you have a blue popsicle stick, can you please stand? So now they infected you. So once they infected you, now you can infect any other blue popsicle sticks around you. And so that's how an infection can spread through a population. It can start with 2 people and then move to all the other susceptible people. You can go ahead and sit down. Vaccinations work by breaking this chain of infection. So if I'm vaccinated and you're infectious, you're not going to infect me, and I can't infect everyone around me. Oops. So if we look at these populations where here you have in the red people that are infected, and then in blue the people that are susceptible, you can see that just starting with 2 people, this infection can run through the entire population because there's nothing to stop it. But when you have people in yellow who are vaccinated, the infection still can spread, but not as much, right? Because it's being stopped by all these people who are protected against it. And this is called herd immunity.
Say that again,
Herd immunity, yeah, herd immunity, yeah. So the more contagious a pathogen, or the more easily it spreads to people, the more people within the population need to become vaccinated in order to achieve this herd immunity. So for something like measles, which is very contagious, it requires that 95% of the population is vaccinated to get this herd immunity. Well, why do you need to be vaccinated if you can just be protected against herd immunity, right? Well, if we see here, there's some people that are vaccinated and then some people that aren't, and so they're still susceptible. So let's talk about those susceptible people. Susceptible people can be people that are sick. They might be undergoing treatments like treatments for cancer, or they have an autoimmune disease that weakens their immune system, so they're susceptible. Pregnant women can't get all of the vaccinations, so they're susceptible. Young children, they might be too young to get a vaccination, and just in general, they're more susceptible because they haven't built any immunity yet. And then elderly people have also a weaker immune system just due to their age. So if we think about measles and 95% of the population needing to be vaccinated, how much of the population do you think these people make up? Right? That last remaining 5% might be a lot of these people. So there's no room for people to not get vaccinated. And when you don't get vaccinated, you create holes in this protection that herd immunity makes, and you put those susceptible people at risk. So what did we learn today? Well, we know now that vaccines teach our immune system what a pathogen looks like so that it can fight it off better the next time. Serious adverse reactions do occur, but it's in less than 1% of people, and it's usually due to an allergic reaction. So something that you can avoid most of the time just by a conversation with your doctor. And being vaccinated is necessary not only for your health, but for the health of your community. So now we're going to hear a little bit about the epidemiology of vaccines from Brianna. Thank you.